At the time of its launch, NASA did not realize that the Voyager mission would end up being one of the most successful space expeditions in history. The Voyager probes, launched in the 1970s, have diligently observed not only Earth but also everything within our solar system and beyond. Despite having a memory capacity 3 million times smaller than our smartphones and being 38,000 times slower than our fastest 5G internet connection, these remarkable spacecraft have provided humanity with consistently new and astonishing information about space. Now Voyager 1 has made a terrifying discovery within the depths of interstellar space, prompting the government to take decisive action by shutting down this legendary mission. What exactly did Voyager 1 encounter, and could we be on the verge of an extraterrestrial invasion? Let's find out. When it comes to US space missions, the Apollo mission takes the spotlight for successfully landing the first humans on the Moon. However, there is undoubtedly another extraordinary mission that stands tall alongside Apollo, and that is the Voyager mission. This exceptional undertaking not only holds the record for the longest-lasting space mission but also holds the distinction of being the first to explore the outer planets of our solar system, from Jupiter to Saturn, Uranus, and Neptune. The Voyager probes, in particular, are considered the most suitable for potential encounters with extraterrestrial life thanks to their comprehensive preparation. Each Voyager spacecraft carries a remarkable golden record containing a compilation of sounds, images, and greetings from Earth, serving as a snapshot of humanity and showcasing Earth's rich diversity, a gift that any potential alien civilization could appreciate. But what if these remarkable probes were to encounter a hostile extraterrestrial race? From the signals we are currently getting, this is possibly what Voyager 1 has to handle right now. This possibility has left scientists pondering the potential consequences, as such an encounter could prove more disastrous than initially imagined. Keep watching as we will delve into the events that led to the government's decision to shut down Voyager 1 and discuss the potential ramifications. Before we delve into those details, let's introduce you to some important context. On September 5, 1977, Voyager 1 embarked on its space odyssey from Cape Canaveral in Florida. It was catapulted into space by the Titan IIIe Centaur rocket only 15 days after its twin, Voyager 2, commenced its own celestial expedition on August 20, 1977. Their primary mission was to investigate the massive gas giants of our solar system, namely Jupiter and Saturn, and their orbiting moons. However, these intrepid travelers exceeded all expectations by venturing deep into our cosmic neighborhood, shattering numerous records along the way. They have surpassed all other spacecraft in longevity and have journeyed farther from Earth than any human-made object, astonishingly even breaching the threshold of interstellar space, venturing into uncharted realms of our galaxy. Presently, Voyager 1 and Voyager 2 reside over 12 billion miles away from our planet, continuously astounding scientists with their remarkable discoveries. Recently, they made an unforeseen revelation that caught the entire scientific community off guard. The Voyager twin probes have accomplished extraordinary feats. More than 4 decades ago, they unveiled the enigmatic moons of Jupiter and Saturn, leaving scientists dumbfounded. These celestial bodies were once regarded as lackluster and crater-ridden, similar to our own moon. However, Voyager exposed their vibrant and dynamic nature. In 1986, Voyager 2 became the first and sole spacecraft to venture into the realm of Uranus, swiftly followed by a thrilling encounter with Neptune a mere 3 years later. As these impressive spacecraft press onward with their inspiring odyssey, NASA has implemented ingenious measures to ensure their operational longevity. By deactivating superfluous components and heaters, power is conserved, enabling the spacecraft to remain robust until at least 2030. The dedicated scientists and engineers behind the Voyager missions were taken aback when an astonishing discovery came to light, so mind-boggling that it prompted the government to intervene in one of NASA's most prestigious projects. But before we discuss that, let's discuss the reputation of the Voyager mission. Why is Voyager 1 such a big deal, and how has it transformed our understanding of space? Among the ranks of iconic missions like Apollo 11, the Hubble Space Telescope, Mars rovers, and the James Webb Space Telescope, the legendary Voyager program stands as a beacon of inspiration for future generations of scientists and astronauts. The data transmitted by the Voyagers has yielded invaluable insights, ignited countless scientific discoveries, and sparked the imaginations of researchers and space enthusiasts across generations. It is worth emphasizing that Voyager 1 and Voyager 2 were no ordinary spacecraft. They were meticulously crafted to function as stable platforms with a rotation rate more than 15 times slower than the hour hand of a clock. This deliberate design ensured minimal blurring of images and data as the spacecraft hurtled through the vast expanse of space. Their impressive imaging capabilities continued to astound scientists and the general public alike, even before their encounters with the outer planets. As the spacecraft journeyed towards Jupiter, they began beaming back images several months before reaching the gas giant. These initial images, showcasing the swirling clouds and the iconic Great Red Spot, filled NASA's Jet Propulsion Laboratory with pure delight. However, it was the revelation of active volcanoes on Jupiter's moon Io that truly stole the spotlight. Io, slightly larger than Earth's moon, emerged as the most volcanically active body within our entire solar system. The spacecraft's instruments picked up peculiar signals emanating from Io, and the vivid images they captured confirmed these remarkable findings. These images unveiled towering volcanic plumes and a surface marked by the ejection of volcanic material. Notably, one of Io's prominent volcanoes, Pelée, erupted to heights exceeding Mount Everest by a staggering 30 times, blanketing an area nearly equivalent to the size of France. In total, the Voyager spacecraft snapped over 33,000 images of Jupiter and its moons, unveiling the planet's breathtaking beauty and the astonishing diversity of the Jovian moonscapes. Before delving into the recent mind-boggling discovery, it is crucial to remember that the twin Voyagers have been unearthing a wealth of astonishing findings since their momentous launch. One of the most astounding revelations was the existence of Jupiter's rings, which, although faint, added an extra layer of intrigue to the colossal gas giant. Moreover, Voyager 2 unveiled the icy shell enveloping Europa, one of Jupiter's 53 named moons, estimated to possess a thickness surpassing 60 miles. These groundbreaking findings challenged previously held assumptions about these distant celestial bodies, sparking a renewed fervor in investigating the potential habitability of icy moons. As the Voyagers bid a fond farewell to Jupiter, they gratefully received a gravity assist that bestowed upon them a vital boost, propelling them towards the enchanting realm of Saturn. Without this ingenious maneuver, their escape from the Sun's gravitational pull and their subsequent voyage into the depths of space would not have been possible. And so, Voyager 1 and Voyager 2 embarked on separate trajectories, each venturing towards uncharted frontiers, eagerly seeking new wonders to unravel. Voyager 1 embarked on a trajectory that took it near Saturn's moon Titan, which is surrounded by a hazy orange atmosphere. Scientists became intrigued by the mystery surrounding this moon, prompting them to conduct further studies on its intricate chemistry. Voyager 1 then changed course and headed north, moving away from the plane of the planets, beginning its remarkable journey beyond the boundaries of our solar system. Meanwhile, Voyager 2 embarked on an exciting series of adventures that carried it to the outermost planets of our cosmic neighborhood. In 1986, it achieved a historic milestone by flying by Uranus, where it unexpectedly discovered 10 previously unknown moons, increasing the moon count of this planet. 3 years later, Voyager 2 reached Neptune, revealing the extraordinary characteristics of this distant ice giant. During its encounter with Neptune, the spacecraft recorded wind speeds of up to 1,000 miles per hour, marking the fastest wind ever observed on a planet within our solar system. By zooming within 2,980 miles of Neptune's methane atmosphere with its azure hue, Voyager 2 provided unparalleled insights into this distant world. Triton, Neptune's largest moon, turned out to be one of the coldest places in our solar system, with surface temperatures dropping to a bone-chilling -391 degrees Fahrenheit. Triton also possessed distinctive attributes such as ice volcanoes ejecting nitrogen gas and icy particles up to 5 miles high into its thin atmosphere. These discoveries expanded our understanding of the remarkable diversity and complexity of celestial bodies, extending even to the farthest reaches of our cosmic neighborhood. One individual who played a crucial role in extending the missions beyond their initial objectives was the esteemed astronomer Carl Sagan. As a member of the Voyager mission's imaging team, he passionately advocated for capturing one final set of images before deactivating the cameras on both spacecraft. These images would serve as a parting gift to humanity, providing a final glimpse of our home planet from the distant depths of space. Sagan's persistence paid off. On Valentine's Day in 1990, Voyager 1 turned its camera back toward the inner solar system and took a series of 60 photographs. The most iconic of these images, known as the pale blue dot, remains an unforgettable symbol of our place in the universe. Captured from an astounding distance of 3.8 billion miles, it stands as the farthest image of our planet ever taken. Earth appears as a tiny pale blue dot, barely visible in the vast expanse of space. This mission has been ongoing for nearly half a century, leading many to compare it to more recent space missions. One such mission that has made impressive scientific contributions is the James Webb Space Telescope, JWST. Although their objectives and scopes differ, both projects have pushed the boundaries of human knowledge and expanded our understanding of the universe. The Voyager spacecraft were marvels of their time, equipped with cutting-edge instruments and systems that allowed them to withstand harsh conditions and maintain communication with Earth across vast distances. Similarly, the JWST incorporates state-of-the-art technologies such as a deployable sun shield to protect its delicate instruments from the sun's heat and a large segmented mirror to capture faint infrared signals. The Voyager program focuses on our immediate cosmic neighborhood, while the JWST aims to unravel the mysteries of the universe on a broader scale. Its advanced capabilities will enable scientists to peer back in time, observing the earliest galaxies and shedding light on the formation and evolution of our cosmic environment. What strategies were employed to guarantee the success of the Voyager missions? Imagine, nearly 50 years ago, in August and September 1977, NASA embarked on a monumental mission that would forever change our understanding of the universe. With unwavering determination, they launched a pair of robots into the vastness of space, armed with a revolutionary technique known as gravity assist maneuvers. These maneuvers would prove to be the key that unlocked the secrets of the solar system and propelled humanity into the realm of the unknown. Picture this, a cosmic ballet where the spacecraft gracefully embraced the gravitational forces of the mighty planets, harnessing their power to soar towards their intended destinations. Rather than relying solely on their own engines, the Voyagers elegantly utilized the immense pull of the celestial giants to slingshot themselves across the cosmic stage. It was a stroke of genius and an ingenious maneuver that conserved precious fuel and propelled the spacecraft with unprecedented velocity, enabling them to embark on an extraordinary grand tour of the solar system. At the heart of this technique lies the concept of gravity assist, also known as the gravitational slingshot. As Voyager 1 approached Jupiter, a majestic gas giant with a gravitational force that defies comprehension, it required meticulous precision to orchestrate the perfect encounter. Guided with the utmost care, Voyager 1 gracefully swung by Jupiter, harnessing its gravitational pull to accelerate the spacecraft with an awe-inspiring burst of speed, a cosmic oomph that propelled it further into the depths of space. Yet executing such a maneuver demanded an exceptional level of skill. These gravity assists became the driving force behind the breathtaking odyssey of Voyager 1 and Voyager 2 through our solar system. Consider the monumental achievements made possible by these slingshot maneuvers. Voyager 2, propelled by gravity assists from Jupiter and Saturn, embarked on a daring voyage to Uranus and Neptune, completing the inspiring Grand Tour. It was a triumph of human ingenuity and exploration, owing an immeasurable debt to the precision and finesse of these gravity assists. Voyager 1, venturing boldly into interstellar space, was followed closely by Voyager 2, both propelled by the cosmic pushes provided by these maneuvers. The concept of gravity assists may seem deceptively simple, but its execution is a testament to the brilliance and dedication of the individuals behind these missions. The Grand Tour undertaken by Voyager 2 demanded meticulous precision, where missing even a single slingshot could have spelled doom for the mission. Yet, with unyielding determination, these pioneers of exploration pushed the boundaries of what humanity could achieve, driven by an insatiable thirst for knowledge and a burning desire to unravel the mysteries of the cosmos. While the gravity assist maneuvers played a pivotal role in navigating the cosmos during the Voyager missions, they were not alone in ensuring the success of these daring endeavors. Enter the Deep Space Network, DSN, a lifeline connecting us to our intrepid Voyager probes as they ventured into uncharted territories. Think of it as the interstellar communication network, a tapestry of colossal radio antennas strategically positioned across the globe. These monumental dishes, ranging from 26 to an astounding 70 meters in diameter, acted as cosmic beacons, enabling vital communication with the spacecraft beyond our planet. Imagine the Voyager mission as a grand odyssey propelled by a remarkable artifact that transcends time and space, the enduring 8-track tape. This remarkable artifact serves as a cosmic time capsule, housing invaluable scientific knowledge as it hurtles through the vastness of the universe. Unlike standard consumer cartridges, the 8-track tape recorders used on the Voyager probes were a marvel of engineering, featuring a reel-to-reel storage system designed by Lockheed and manufactured by ODC Corporation. These impressive machines boasted specific specifications, offering flexibility and precision recording speeds, included options of 115.2 kilobits per second (kbps) and 7.2 kilobits per second, while playback speeds ranged from a maximum of 57.6 kilobits per second to slower options of 33.6, 21.6, and 7.2 kilobits per second. The reliance on these exceptional 8-track tape recorders within the Voyager mission exemplifies humanity's unwavering dedication to scientific exploration. As these probes venture deeper into the cosmos, the enduring legacy of this timeless relic continues to preserve and disseminate our insatiable thirst for knowledge. The Voyager missions have sparked awe and wonder in us all, propelling us to venture into the vastness of interstellar space. But before we delve into the discovery that led to the shutdown of Voyager 1, let's look at other fascinating interstellar missions, Pioneer 10, Pioneer 11, and New Horizons. These missions have played a pivotal role in expanding our knowledge of the solar system and beyond. Picture this, it's March 2, 1972, and Pioneer 10 sets off on its groundbreaking expedition. It becomes the first spacecraft to venture beyond the asteroid belt, venturing into the uncharted territories of the outer solar system. Its mission, to conduct flybys of Jupiter and its enigmatic moons. On December 3, 1973, Pioneer 10 achieved an extraordinary feat. It became the first human-made object to journey through the asteroid belt, offering us invaluable insights into this mysterious region of space. But the excitement doesn't stop there. Pioneer 10 dazzles us with breathtaking images and crucial scientific data as it performs a close flyby of Jupiter, capturing the essence of the gas giant and its captivating moons. Pushing further into the unknown, Pioneer 10 becomes the first spacecraft to cross Neptune's orbit in June 1983, etching its name in history. Even though we lost contact with Pioneer 10 in 2003, it forever remains the trailblazer, the first man-made object to venture into interstellar space. Following in Pioneer 10's footsteps, Pioneer 11 takes the stage on April 5, 1973, with similar objectives. It embarks on a daring adventure. December 2, 1974, marks a remarkable milestone as Pioneer 11 successfully conducts a flyby of Jupiter, treating us to awe-inspiring images of the gas giant and its iconic Great Red Spot. But Pioneer 11 doesn't stop there. It embarks on a grand mission to unravel the mysteries of Saturn and its enthralling moons.